Hello everyone and welcome back to my YouTube channel. So friends, today we are going to study about acid, base and salt. Well, in this chapter, I am going to tell you what is acid, what is base and what are the salts. So before studying that, we need to identify what is an acid, which solution contains an acid. So before moving to the lecture, first of all, like my video, share my video and yes, subscribe my channel. Below the video, you can see there is a bell icon and a subscribe option. When you click on the bell icon, the next video's notification automatically comes to your screen. So now I am going to tell you about acid, base and salt. Before going to that, from where does this concept came? So friends, you know that elements when joined together, they form compounds, right? So when we classify compounds on the basis of their chemical properties, I am repeating, classification of compounds on the basis of their chemical properties is divided into further three parts. One is acid, second is base and third is salt. So now, before studying what is an acid or base or salt, we need to identify that whether a substance contains an acid or it contains a base. So to identify that a substance contains acid or base, we need indicators. Now I am going to tell you about indicators. So students, you would be seeing some pictures here that shows the various kinds of indicators. What does indicators do? They just help us to recognize between an acid and a base. See, now what are the indicators and what is their effect and how does it shows us that a substance contains an acid and base? So indicator is a dye, okay, a type of dye that changes its color when it is put into acid or base. Now see what happens when we put a substance, like we put a litmus paper into a solution. So when its color changes, that indicates us something. That indicates us that it is an acid medium or a basic medium. So indicator basically refers to indicate, to identify, to recognize. Okay, so now to indicate that a substance contains an acid and base, when it is put into the solution, you need to see this, that indicator is something that we put into the solution. Okay, like it can be a drop. When we put on the litmus paper, we can put a drop of it or we can dip it into a solution. So there are various ways to do that. Before that, I would tell you that they are further classified. Indicators are further categorized into two types. One of the indicators are that shows different colors in acidic and basic medium. As I already told you that we need to dip the litmus paper into a solution. That can be an acidic solution or a basic solution, which shows the different colors. Litmus is an example of that. Okay. And the other kind of indicator I am talking about is that indicators giving different odors. What is odors? It's a smell. Okay. In acidic and basic medium. They are known as olfactory indicators. Now you would be seeing that you can see a stain of vanilla extract on your shirt piece, or you can see onion smell in one of your shirts when you eat onion and it just falls off, and you after some time you see there's a smell of onion and you are not getting rid of it. So what do? You indicate it, you with the help of a substance, you check it out that basically it is an acidic medium or it is a basic medium. So to check that indicators are olfactory, which causes a different odor, a very unpleasant smell. So that identifies that indicators can be further classified into two categories, one showing the different colors and the other one showing the different smell. Okay, so now I am going to tell you both of them in detail with some examples. So now I am going to tell you about the indicators that are classified on the basis of their color. Friends, see, there are various type of indicators that tell us about the different colors when put into a solution of acid or a base medium. One of the indicator which is very common and is usually used in the laboratory, so that is the litmus indicator. Okay, you can see a red litmus paper or a blue litmus paper and a litmus solution. Okay, so litmus can be found in two forms, that is in the form of litmus paper and in the form of litmus solution. So I am going to tell you in detail after this classification. So first of all, I told you about litmus paper. You can see the diagram also. Then the second kind of indicator is the phenolphthalein. This kind of indicator which turns something, which turns the colors. Okay, I'm going to tell you which color is converted into which when it is put into acid or a base medium. So you need to see the examples of the indicators. So litmus is the one, second is the phenolphthalein, the third one is the methyl orange. It also acts as an indicator, but it is a synthetic indicator. I am going to tell you what is synthetic indicator in detail when I will tell you about methyl orange. So you can see the pictures of phenolphthalein also and of the methyl orange indicator also. Now comes the next kind of indicator, that is the flowers. The petals, which are colored petals of the flowers of the hydrangea, petunia and geranium. These three flowers have colored petals and these colored petals act as an indicators. Okay, so you can see the example and the pictures on this. Now comes the next kind of indicator, that is the turmeric, which is very commonly found in the kitchens in every house. So you can see turmeric, which is also called haldi in Hindi. Okay, so this is the picture of the turmeric indicator. Now comes the last kind of indicator, that is the red cabbage extract. This is also one kind of indicator which is also a natural indicator. So I use the two terms synthetic indicator and the natural indicator. I will now discuss both of these terms while explaining you all of these indicators in detail, and I am going to tell you which color is being changed to which when they are put into acid or base medium. So here I go. So now I am going to explain you about litmus. What is litmus and what are the color changes that we observe when we dip a litmus paper into an acid solution or into a basic solution. So first of all, you need to write that when a solution is said to be acid, it will convert the blue litmus into the red one. Okay. And when a solution is referred to as base, then it turns the red litmus to blue. Okay, so these are the things that you need to learn. Now the question arises in exam that what are the color changes when a litmus is put into an acidic medium? So you have to write that the blue color changes to red. And what are the changes when the litmus is dipped into a basic solution? When it is dipped into a basic solution, the color changes will be red litmus will turn into blue color. Okay. Now, what is the neutral color of litmus paper? The neutral means that in between, it is neither an acid nor a base. So, the neutral color is purple. When the solution is neither an acidic solution nor a basic solution, the solution is referred to as neutral and the color that arises on the paper, litmus paper, that is the purplish color. Now, students, litmus is known as a natural indicator also, which is very common indicator and it is used in laboratory purposes. Now, one thing more, from where does the litmus is extracted? As I told you, it is a natural indicator, so it is extracted from the plant lichen. Now, this is a question for the bio students also, but you need to understand this, that it is extracted from the plant lichen whose division is Thallophyta. Okay, so in class 9th you have studied about the divisions also. Hope it would be easy for you to learn this. Now, one of the example of litmus is orange juice. So, orange juice is acidic in solution. So, when you put a drop of orange juice on the litmus paper, what do you observe? You observe the color changes from blue litmus to red. That is, it means it is an acidic solution. So, you just have to put a drop or you have to dip into the solution. Then, the color change indicates about the solution. As I told you, orange juice, when you put a few drops of it, it changes to red color. So, when does it changes to red color? In the case of acidic solution. Hence, orange juice is acid. So, Now I'm going to tell you about the next kind of indicator. You can look up to the pictures of litmus paper. So now I'm going to explain the next kind of indicators. One of them is methyl orange and the other one is phenolphthalein. What is methyl orange? It is a kind of indicators that tell us whether a substance is acid or a base. Now, how can we recognize that substance is acid? To recognize it, we should know that when a substance is dipped into the acidic solution, it turns into red-orange color. That means it is an acidic solution. And when a substance is dipped into a solution and its color changes into yellow, that means it is a basic solution. So to identify an acidic solution, the color should change to red-orange, and to identify a basic solution, the color should change into yellow. So this is the identification of methyl orange. But one thing, students, before I told you that litmus paper has a neutral color, that is when it is neither an acid nor a base. Similarly, in methyl orange, the neutral color is orange when it is neither an acidic solution nor a basic solution. So the color that we observe, that is orange in color. Now, one thing more, it is a type of synthetic indicators. We don't obtain this naturally as we obtained it in lichen. You know, we obtained litmus from lichen, but we didn't obtain methyl orange from anything. From naturally, we didn't take it out. So now, the next kind of indicator is phenolphthalein, which is also a synthetic indicator, which is not found naturally. So now, you can see the picture of methyl orange over here. Now I'm moving forward towards the phenolphthalein. As I told you, it is also a kind of synthetic indicators. So when you put a solution in and the color changes into pink, then the solution is referred to as the basic solution and the indicator is phenolphthalein. And when there is no change in color, it is already colorless. You know, there is no color. Basically, its neutral color is colorless. That is when it is neither an acid nor in basic, it is a colorless solution. And when you put it into a solution and it remains colorless, that means it is an acidic solution. But when it changes into pink, that means it is a basic solution. So, you can see the difference between both these indicators, that when the acidic solution turns into red-orange, that the indicator is known as methyl orange. But when it changes into pink color, then it is the basic solution and the indicator is known as phenolphthalein. So the question arises, like, identify the indicator and the color change when you observed. So they'll give you a substance, they tell you the color change. Like for example, they say you that the color change is colorless. The substance is colorless. So how can you identify which solution it is and what is the kind of indicator? So the solution is acidic solution and the indicator is phenolphthalein because the material which you put in into the solution, it remains colorless. It has no color. When it will have the pink color, it will be a basic medium. So now we'll move forward toward the next kind of indicators. So now comes the next kind of indicators. Now these indicators are the natural indicators. Now friends, what are the indicators? One of them is turmeric, second is red cabbage extract, and the third one is the flowers with the colored petals. Now first I am going to tell you what is the turmeric and how it behaves as an indicator. As I told you, turmeric is a natural indicator and yes, it is found in each one of your house. It is known as haldi in Hindi. It is yellow in color and also referred to as a yellow dye. Now what happens? It turns red in the basic solution. Now friends, you have observed that when you eat curry in your lunch, you see some of the kids throw curry on their clothes. Now what happens? Their mothers take that shirt and when they wash that shirt, you observe that it turns into reddish brown color. Why does it change into reddish brown color? Has anyone noticed that? Because the base acts on it. The soap acts as a base and when it is rubbed on the cloth, it turns into reddish brown. And when water is put into it, what happens? The color vanishes away and the yellow color again appears. Note this down. First, what happens when you rub it with a soap solution, it turns into reddish brown, and when you put some kind of water on it to wash it more nicely, it turns into yellow. It is not a magic, it is an indicator. So, haldi acts as an indicator. It is a yellow dye, also known as turmeric, and it turns red in basic solution. As you know, soap is a basic solution, that's why it converts into reddish brown color. Now, I am going towards the red cabbage extract. Red cabbage extract is also a natural indicator because we obtain it from the red cabbage leaves. And yes, it acts as indicator because it also shows some color changes. See, when it is put into the acidic medium, it remains red. It does not change. But when it is put into a basic medium, it turns into green color. It's a new color, you have to learn it out. So, now what do you see? It is also kind of natural indicator which is obtained from red cabbage leaves. It is basically red in color and it remains red in acidic and turns green in basic. Now, I am coming forward towards the flowers. As I told you, flowers with colored petals, for example, hydrangea, example, petunia, and the last one, geranium. These three kind of plants have the colored petals which act as indicators. Yes, you can see the example of hydrangea. It is usually blue in color, but when put into a basic solution, it turns into pink. So it also acts as an indicator. Now, I am looking forward towards the next kind of indicators, that is indicators which show different odors. That means the different smells. So here I go. Now comes the last kind of indicators, that are the olfactory indicators. As I told you, olfactory indicators depends upon the odor and the smell. Now, what happens in this? You know, the olfactory indicators are related to the sense of smell. That means you will smell and tell whether a substance contains an acid or a base. Now look after this. It is basically observed when smell changes in acidic and basic solution. So friends, you have to keep note that olfactory indicators just depends upon your sense, the sense of smell. When it is smelling and you can identify it as an acid or basic. There is no need to dip a solution into something. No. Now see what happens. When acid or base is added, here acid or base is added, then the characteristic smell can't be detected. What I am saying, look forward to this with the help of an example. When I talk about onion, onion has a very unpleasant smell, you know that. So when we dip the basic solution, that is NaOH, to the cloth. For example, a cloth contains a smell of onion. You eat something and there is a smell of onion, like onion extract is there. So now what you can do is, if you rub NaOH through it, you will observe that the onion smell can't be detected. The unpleasant smell gets rid of from the cloth piece or from the surface where the onion extract was present. So now what is this? That means that base cannot detect the smell. Means the base we can identify the base by looking forward. That smell disappears, it means it is a base. And if the smell remains, it means it is an acid. Now see, I said when NaOH is added, the smell can't be detected, means it gets disappeared. But when HCl, that is an acid, it is added, it does not destroy the smell, it remains the unpleasant. It means if the smell remains, that is an acid, but if the smell disappears when we put NaOH, it is a base. Now when we look to the next example, we see that vanilla extract. You all have seen the vanilla ice cream, right? That is the vanilla extract. It has a very pleasant smell, very nice smell. Small kids love ice creams, usually the vanilla ice creams. So, the vanilla extract has a very pleasant smell. When you put NaOH, the smell cannot be detected. Hence, it is a basic solution. But when you put in HCl and the smell doesn't get destroyed, it is still present there. This means when you put NaOH, the smell gets rid of. It means it is a basic solution. But when you put an acid, the smell does not goes off. It means it is an acidic solution. So, through this we can identify the olfactory indicators, that is through the sense of your smell. So here I conclude my video and hope so you would have understood about indicators. Now in my next lectures, I would be telling about acid, base and salts. Hope you like my video. Do share my video and yes, subscribe my channel named as Shourya Grover. Thank you.